Hello students, as in this lecture we're gonna start with a new chapter, that is a complex number, which is easy, interesting and a beautiful chapter. And this chapter it is for both the section for commerce as well as science. Okay, I guess this complex number you had heard for first time. Okay, as you might be knowing what is a natural number, whole number, even number, odd numbers, real numbers, but this complex number, I guess this part actually it was not there anywhere in your lower standard. Yes or no? So this section, it is a new, complete new for you all. Okay, so you don't know anything head or tail about this chapter. Okay, so again I will say this is one of the easy, interesting and beautiful chapter from max. Okay, and this chapter it is for both science as well as for commerce. So let's see what do you mean by complex number first. Okay, I hope you all might be knowing there are real numbers, yes or no, and one section it is known as what, imaginary numbers. So one is what, real number, second one is what, imaginary number. The complex number come under the imaginary numbers. Real numbers are what, the numbers like natural number, whole number, rational, irrational types number. Okay, then in that all the numbers like even number, odd numbers, it comes under the real numbers. Okay, and imaginary numbers is what, in which complex number come. Okay, so complex number indirectly or directly they are one and the same. Imaginary and complex are the one and the same. Okay, so there are two types of number in mathematics, one is real and one is imaginary number. Okay, so complex number is what, the imaginary number. This chapter, the mathematician who had framed this chapter, who designed this chapter, just by imagination. Okay, it just developed, he had framed this chapter. So why and how, that we will see how he got the idea to make this chapter. Okay, so now as complex number, we know that it is just an imaginary chapter, imaginary. So that's why we say the numbers in this chapter is what, imaginary. Okay, so complex number is what, a number of the type a plus bi. The number of the type a plus bi. So basically we represent the complex number as a plus bi. Now see, listen here, each and every chapter has its own format. Like suppose if I say the name of the chapter is linear equation in two variable, yes or no? So when I say linear equation in two variable, it will have its own format, that is a x plus by equals to c. This is known as what, linear equation in two variable. Suppose if I say a chapter name is quadratic equation, so the chapter will has its own format. So we write the quadratic equation as ax square plus bx plus c equals to 0. So it means what, each and every chapter has its own format. So complex number also has its own format. We write the complex number as a plus bi. Sometimes we write it as z equals to a plus bi. Okay, z is nothing but it is what we say, it represent a particular point, a single point. Z is what, represent a particular point with respect to x and y coordinate, with respect to x and y coordinate. Okay, just forget about this in detail. Just remember, we represent the complex number as a plus bi, and or else sometimes z equals to a plus bi. So these are the format in which we represent the complex number. So here, what is a and b? A and b are the real numbers. A and b are the real numbers. Real numbers means what, in place of a and b there will be a number like 3 plus 2i, minus 3 plus 2i, or minus 3 minus 2i. So in place of a and b there will be a number. Either it will contain positive number, negative numbers, or the number it will be in fraction. Okay, real numbers. And I is called as the complex number. I here is called as what, complex number. So now we'll see the mathematician who created, who designed this chapter, why it took I, what was the reason behind that. Okay, now suppose if I say square root of 4 is what, so what will be your answer? So what you will say, the square root of 4 is what, 2. If I say square root of 9, so what you will say, 3. Okay, we'll take the positive answer only. Okay, so square root of 16, so what will you say? You will say 4. This is the answer. Suppose if I say, if you want to find square root of minus 4, what will be the answer? Square root of minus 4. We know that square root of any positive numbers, we can easily find the square root, yes or no? But whenever we have a negative square root, the square root of real numbers cannot be negative. Remember this, because this actually we had studied in the quadratic equation, as whenever b square minus 4ac, this section b square minus 4ac, if it is greater than 0, it has two real roots, yes or no? If b square minus 4ac is equals to 0, it means it has equal root. If b square minus 4ac is less than 0, it has no real roots. Okay, this part actually you might be knowing, it was there in the quadratic equation. So taking the help of this part, okay, I will try to explain that how we add frame this chapter, how we got the idea that he has to take I. Okay, so here can I say square root of real number cannot be negative? Means in simple language, if we have to find the square root of any negative number, we cannot able to find our answer. Okay, we cannot find the answer as it is not there in the mathematics. Okay, till 10th standard we was knowing that the square root of real number cannot be negative, and we cannot able to find the answer of if you want to find the square root of any negative number, yes or no? But here we can solve in this chapter. How? That we'll gonna see. So as we know that if here this answer is less than 0, less than 0, less than 0 means what? Negative. So inside square root, if negative is there, so we cannot able to find our answer. In the same way, square root of minus 9, we cannot find our answer. In the same way, minus 16 also we cannot find our answer. So what he decided, what he did, he wrote this 4 as minus 4 as 4 into minus 1. Can I write 4 as 4 into minus 1? I guess, yeah, did the same thing. Then after that, can I write this minus 9 as 9 into minus 1? Still you will get the same answer, yes or no? Got the point? Okay. Then can I write this root 16 as same 16 into minus 1? So I decided that I will break this minus term as into minus 1, into minus 1, and into minus 1. So whenever we have to find the square root of any negative number, so we'll break like this. Okay, 4 into minus 1, 9 into minus 1, 16 into minus 1. Okay, now after this, can I write this root 4 into root minus 1 as root 4 into root minus 1? Yes or no? Here I will show root minus 4 I can write as what? 4 into minus 1, because we know that square root of any real number, it is not negative. Okay, if inside, okay, so square root of real number cannot be negative, so we can write this as 4 into minus 1. Further, can I split this as root 4 into root minus 1? Yes or no? Root 4 into root minus 1. Yes, we can write root 4 into root minus 1. As the orders are same, so we can multiply. Okay, if you multiply this, you will get the same answer. Got the idea what I did here? Okay, so in the same way here also, for minus 9, I will write this as 9 into minus 1. I can write this further as 9 into root 9 into root minus 1. Okay, so minus 16, so this we can write as what? 16 into minus 1, and further this we can write as root 16 into root minus 1. Okay, now listen here. Root 4 we know that it is 2. Root 9 it is known as 3. Root 16 is what? 4. But here what about this root minus 1? Root minus 1, in all the cases we are getting this root minus 1 as common. Okay, and because of this number we cannot able to find the further answer. That means it shows that whenever a negative number it is there inside the root, we cannot find our answer, because square of a real number cannot be negative. Okay, so but in this chapter we know that we can able to solve our answer. So the mathematician who had created, who had designed the chapter, he might have decided that let's be let's imagine that in place of this something is there. In place of root minus 1 something will take. So it decided to take in place of root minus 1 I. So I is what, just a imaginary number. It just decided, it just imagine, let's take some alphabet, and it decided to take I. Why I? Because it is the first letter of the word imaginary. Okay, that I can say. Or else I is also known as iota. I is also known as iota. I is also known as imaginary. So we'll use the word imaginary, which is perfect. And we can say that imaginary first alphabet is what? I here. Okay. Okay. So here I just decided that let's take in place of root minus 1 will consider, because in each and every case, can you see, whether it is root 20, root minus 25, whether it is root minus 64, in all the cases you will get root minus 1, root minus 1, root minus 1, root minus 1 common. So then I guess he might decided that let's take some imaginary thing in place of root minus 1, so we can solve the sum further. So just to solve the sum further, he decided in place of root minus 1 will write I. So I is what? It's imaginary number, mathematicians imaginary number. So he decided to write I in place of root minus 1. So in this way he has created his chapter, he had designed his chapter called as complex number. Okay, got the idea? Okay, so once again we'll see root minus 4. We know that we cannot write, so root minus 4 we can write as root 4 into minus 1. Same, root minus 9 we cannot find the answer, so we can write it as 9 into root, or 9 into minus 1. Further, this we can write as 4 into root minus 1. This we can write as root 9 into root minus 1. So in the both the cases here we are getting root minus 1 common. So he decided to take this root minus 1 as imaginary thing. So in place of that number root minus 1 will take some alphabet, so he decided to take I. Okay, so what is I over there? It is imaginary, it is the first word of imaginary, that is I. So in this way he created his formula, that is I equals to root minus 1. Got the idea? Understood? Okay, so after that he wrote this root 4 as 2, and in place of root minus 1 he wrote I. Root 9 as square root of 9 as 3, and in place of root minus 1 as I. So here we got the value of I is what? Okay, negative square root. Negative square root. The negative square root is known as what? I. And I is known as what? Imaginary number. And a number which contain I. Okay, suppose if you have only 2, 3, 4, 5, without I is known as real number. In short, a number with I, a number with I, a number with I are known as what? The complex number, or the imaginary numbers. Okay, this part will, we can say that this is the imaginary part, so it is a complex number. Okay, in simple language we'll distinguish this. A number without I is known as the real number, a number with I is known as the complex number. Okay, so here we know the format is what? A plus bi. So here A and B are what? So your A and B are called as what? The real numbers. Yes or no? And I is the complex number. Okay, got the point? But here this A, can you see this A? It is without I, so we can say this as real part. And this B, it is with I, so here BI, this B is with I, so here we can say this B is what? Imaginary part. So that only I had explained here. Number without I is the real, number with I is known as what? Imaginary, that means the complex part. Okay, imaginary part we can say. Okay, so sometime we write this complex number as z equals to a plus bi. Z represent what? It is just a single point with respect to the horizontal and the vertical line, so we can consider this as x and y coordinate, like that. Okay, so just remember the format is what? A plus bi. And what is I? I is what? Imaginary number. So what is the value of I? We got from here, that is what? Root minus 1. Root minus 1. Okay, So here we got the value of I as root minus 1. So I is known as what? Imaginary number, or else we can say I is also known as iota, also iota. Okay, iota or else imaginary number. Okay, now here we have to generate, or we have to create the values for I square, I cube, I raised to 4, I raised to 5, I raised to 9, so and so. Okay, now we'll see how to create the values. Okay, as we know that I equals to root minus 1. Okay, suppose if you want to find I square, so simply what you will do, you will square the numbers on both the side. So say taking square on both the side, taking square on both the side, taking square on both the side, yes or no? So your square root will get cancelled, so here you will get what? Minus 1. So yes, here we got the value of I square as minus 1. Okay, so you have to remember this value. So suppose in question, wherever they say that I square is there, so you have to replace the I square by root minus 1. So this is the important concept number 1, we can say, of the complex number, where you must know to generate the values of I square, I cube, I raised to 4, then so on. Okay, so now here we got one value. So now we'll see how to find the value of I cube. Now here, can I write this I cube as I square into I? Yes or no? Can I write this I cube as I square into I? Why, sir? Why you wrote I square into I? And is I square into I is I cube? Yes, I square into I is what? Cube. Or else you might be knowing this formula: a raised to m into a raised to n. Indices formula is what? A raised to m plus n. Suppose here I square is there, and here I in the power nothing is there, so we can consider as 1. So I 2 plus 1. So I 2 plus 1 is what? 3. Yes, I cube we can write as what? I square into I. So you must know to break this value. Suppose if I say I raised to 4. So I raised to 4 you can write as what? I cube into I, yes or no? Or else you can write I cube as I raised to 4 as I square into I square. Now it is on you how you will break the values and how you will find your answer. So just I'm showing to generate how to create the values of I. Okay, so this is the important part, and I will say this is the first important concept where you must know to find the value of I. And in general you understood, I hope you all understood what is a plus b, what is a, what is b, what is I, what is imaginary number, what is the real part. Okay, so from my point of view, so this part will be your important section, important part. Now we'll see how to find the value of IQ. As we know that I square is what? Minus 1, will write as it is. And what about I? We know that I is what? Root minus 1. Now note, in place of I you will keep the I as it is. We have to replace the value only for I square, I cube, I raised to 4, because we are dealing with the chapter called was complex number. Complex number is what? The number with I. If I is not there, so what the idea understood? So whenever you see I anywhere, when you break and you see I anywhere, you will write I part as it is. Don't substitute this value. Okay, if you substitute root minus 1, of course you cannot find the answer, as root minus 1 we had converted into I for what? Just to solve the sum. Okay, so remember, wherever you see I, you will keep the I as it is. Just you have to break the numbers only for I square, I cube, I raised to 4. I will be I. Understood? Okay, so further, minus 1 into I, you will get minus I. So here we got the value of I cube as what? Minus I. So these two are very very important, I can say, formula. Okay, so wherever you see I square you will write minus I, and wherever you see I cube in the question you will replace I cube by minus I. I square is minus 1 and I cube is minus I. Remember this two thing. Okay, so now we'll see for I raised to 4. So we can break this I raised to 4 as by using a raised to m into a raised to n, I cube into I, or else I square into I square. So we'll check in both the cases what answer we are getting. I cube just now only we got, that is minus I. Yes or no? And what about this I? Just now only I told I part will be same as it is. Don't change the value, replace the value by root minus 1. Okay, wherever you see I in this chapter, you will keep the I as it is. Note down this. Okay, so yeah, minus I into I. So I into I is what? I square, and this minus will come. Yes or no? Keep this minus as it is. What is the value of I square here? We got it is minus 1. So minus into minus is what? 1. So yes, here we got the value of I raised to 4 is what? 1. Okay, suppose if you break I raised to 4 as I square into I square, so we'll see here I square is what? Minus 1. I square is what? Minus 1. So minus into minus is plus, and 1 into 1 is what? 1. So whether you break I raised to 4 as I cube into I or I square into I, you will get the same answer. So it is on you how you break the values, but see that you must get the perfect answer. Okay, so here we come to the conclusion. So we got the value of I, that is imaginary number, is known as root minus 1. I square is minus 1. I cube is minus I raised to 4 is what? 1. So here I can say these three are very very important. So with the help of this three, you can able to find the value of any answer. Any means any answer. Like suppose if I say, if you want to find the answer for I raised to 7. So now decide how you will break this 7. We can break this 7 as 6 plus 1. We can break this 7 as 5 plus 2. We can break this 7 as 4 plus 3. Yes or no? It is on you. So 4 plus 3 will be very easy because we know the value of I raised to 4 and I cube. Yes or no? So the breaking department, it is on you. How you will break, it is on you. So here I can say that 4 and 3 will be easy. So we can break this I raised to 7 as I raised to 4 into I cube. If you want, you can break 5 to 6 1 also. Okay, but as just now only I told, with respect to this value, you can able to find any answer. So I I will break the 7 as 4 and 3. So I raised to 4, here we have the ready-made value, that is 1. And what is I cube? I cube is what? Minus I. Understood? Got the idea? Okay. So here 1 into minus I will be what? Minus I. So here we got the answer of minus I, minus I raised to 7 as minus I. So in this way you can you can generate your value of any I, whether you have to find I square, I cube, I raised to 4, any value. Okay. Okay, so by breaking this, you can able to find the answer of any values. Okay, there is one more method to find the answer for the bigger values like I raised to 40, I raised to 90. Okay, so this part I will show in the next video lecture. Just remember, for to find the value of I square, I cube, I raised to 4 till I raised to 20. Okay, so this method you can apply. Okay, when the values are bigger, so there I will show the different method also. Okay, so this is the way in which you can. Okay, this is not the only way I am saying. There are one more way, where just simply by dividing by each number, whether it is 7, 8, 9, 10, simply dividing by 4 also we can able to find our answer. But I feel this is the easiest method just to break, okay, with respect to this formula, and find the answer. So now here we come to the conclusion that here we got the value of I as root minus 1, I square as minus 1, I cube as minus I, and I raised to 4 as 1. So at least remember this four things in your mind, at least for the first exercise. Okay, in the next exercise, there we have to find the values for the higher values like 40, 50, 100, 200, 1000. Okay, so there I will show the second method also, by using division, by using dividing by 4. There is one formula. By using this method, I will show how to find the values for the higher numbers. Okay, just remember, for the first exercise, I square is minus I cube is minus I raised to 4 is 1. Understood? Okay, so let's move on to the next thing. I hope you all understood this part. So what is complex number? Once again we'll see. Complex number is what? A number of the type a plus bi. So where a and b will be replaced by some other number. So let's check a as 3 and b as 2. Okay. So in short, in simple language, the number without I is known as what? A real number. Number with I is known as what? Complex number or imaginary number. So here a is what? A real part, and 2 is what? Imaginary part, and together it forms complex number. So complex number format is what? A plus bi, or sometimes we write as z equals to a plus bi. Okay, so let's move on to the next, conjugate of the complex number. So what do you mean by conjugate? Conjugate means what? Okay, it's opposite symbol. Like a plus bi we can write as what? A minus bi. And a minus bi we can write as what? A plus bi. It means here in this chapter you have to change the symbol of I symbol will change, not a. Suppose if I say 3 plus 2i, so it will be what? 3 minus 2i. So conjugate of this number will be 3 minus 2i. If I say 3 minus 2i, its conjugate will be 3 plus 2i. Okay, suppose if I say minus 3 plus 2i. Now here just note down, here I wrote something, that is I symbol will change, only the I symbol, not a part. In short, the imaginary part will change, the symbol of imaginary part will change. Okay, not a. So the answer will be this, minus 3 will be same as it is, so plus will be minus. If I say minus 3 minus 2i, so its conjugate will be what? Minus 3 will be same, imaginary part symbol is what? Minus, so it will be plus. So in this way you have to find the conjugate. Suppose if I say conjugate of 2i, positive 2i, so it will be minus 2i. Conjugate of minus 2i, it will be what? 2i. Understood? In simple language, conjugate of complex number is what? You have to change the symbol of I, that's it. Suppose only number is there, so what will be the conjugate of this number? It will be the same, because conjugate of complex number means what? We have to conjugate the complex number, that means the imaginary part. Yes or no? Okay, just the imaginary part. Just see the symbol of bi part. Okay, don't change the symbol of a, as here I is not there, so how we can conjugate this section? So that will be same. Okay, so these are the small things which you have to remember. Now next part is what? When there is a property, it says that if suppose a plus bi equal to c plus di is there, and it says that the section which is there in the left hand side and the right hand side, they are equal, that means it is balanced. When it is balanced, see to it that you have to compare the real part and the imaginary part. So here in left hand side and right hand side, what are the real parts? A and c are the real parts. What are the imaginary part? B and D is the imaginary part. As they are equal, so its value, its real part and the imaginary part will be equal to each other, just by comparing the left hand side and right hand side coefficient. As this property is known as equality property. Whenever we have a equality property, it means left hand side it is equals to right hand side, so its position value will be equal to each other. As what is there in place of a? C. What is there in place of b? It is g. So in simple language, its real part will be equal, its imaginary part will be equal. Okay, when left hand side and right hand side as the same format, equal to is there, so therefore we can say a is equals to c and b is equals to d, like that. Okay, suppose a plus bi equal to 0 is there, so there you will write a equals to 0 and b equals to 0. Why? Here right hand side only 0 is there. Okay, so that means the 0 is without I, so that we can write as a equal to 0. So what about b? So can I write here it has 0i, 0i. Suppose whenever a number is there, an item is missing, we can write the item by taking the coefficient as 0. So here clearly we can see that I converted this concept a plus bi equal to 0 as a plus bi equal to 0 plus 0 I, okay, in this format. So whenever we have equal symbol, left hand side right hand side format is a plus bi, a plus bi, so its real part will be equal and its imaginary part will be equal. So from this we come to the conclusion that a will be equal to 0 and b will be also equal to 0. Got the point? So remember, whenever it is a plus bi equals to 0, we can write this a plus bi equal to 0 as 0 plus 0 I. So in short, a will be equal to 0 and b will be equal to 0. So that was the property. Understood? So here I guess I hope you all understood the concept. What do you mean by the complex number? So let's have a short revision once again. So I started explaining what is complex number. Okay, as each and every chapter has its own format, like a linear equation, it adds own format, quadratic equation has its own format to write the equation. So here also we have its own format, and I had explained what do you mean by complex number, what how the mathematician got the idea to just to take the value of I there. So here I took some example just to explain the concept more clearly, how we got, why it took I. And we know that square root of real number cannot be negative, so we cannot find the square root of any negative numbers. So what exactly it did, so it took in place of root minus 1 as I. What is I? Is the imaginary number. I can say the first word of the I it took as I, or else it is also known as iota. Okay, so here then after that I'd explain how to generate the values of I square, I cube and I raised to 4. Okay, whenever the values are larger. So in the next video lecture or in the next exercise, there are sums based on this. So there I will explain how to find the answer for the higher values. Okay, so at least you must know for the smaller value how to generate. Okay, so here I had explained everything about that, how to find the answer for I square, I cube, I raised to 4, I raised to 7, like I raised to 9 also you can find. You must know to break the numbers. Okay, that's it. Okay, or else in simple language I will say, for the first exercise just remember these three values: I square equals to I cube equals to minus I raised to 4 equals to 1. And please note down, wherever in the exercise you see I, don't write I as root minus 1. In place of I it will be I only. You have to change the value only for I square, I cube, I raised to 4, then so on. Not for I will be I itself. You have to keep the I there itself. Okay, suppose if I say 3 plus 3 I plus 3 I squares, so this 3 will be same, 3 I will be same. You have to change this part because here I square is there. Okay, got the point? So after that we saw conjugate. What do you mean by conjugate? In conjugate I'd explain which part, which symbol you have to change. Then these two properties, it is very important. So when we will be dealing the sums with respect to the complex number, so this two property will play an important role. I hope you all understood the basic concept of the complex number. So now we can start our sums based on these properties. Okay, so let's take some few example based on the conjugate, then how to find the answer, how to compare the values, and how to find the answer of the real part and the imaginary part. Okay, so in the next lecture we're gonna do that. Okay, till then, goodbye, see you in next lecture.